In this video, I'm going to go through the instructions for completing the Unit 4 Section 3 lab on visualizing Lewis dot structures. There's really going to be two screens that you guys kind of juggle when completing this lab, and it does have to be completed digitally. The first screen is this, the actual lab setup screen. This is where you'll complete your assignment. The second screen is going to be this link right here, moleview.com. And here I'll show you kind of how to set up your moleview.com and what it's used for. So after you click on this link, you'll see this screen pop up. Now, depending on kind of your computer's settings, there might be a few things you have to change. First of all, sometimes this screen pops up with a molecule already shown on the left here. To get rid of that, just double click this trash can button and it should clear your screen. The second thing you'll want to make sure is highlighted is this CH button in the top middle. That'll make the actual molecules shown kind of match what we do in class. And the last thing is if you don't have this split screen of white on the left and black on the right, you'll want to click this view button up here in the top left and change it to side by side. Basically, the point of this lab is we're going to sketch our molecules on the left and we'll see what their structure looks like on the right. So make sure your screen is set up the same as mine is by following those instructions. And I will be flipping back and forth between a couple different screens in this lab instructions. So first, let's take a look back at the lab. Basically, the way this lab works is first you'll see the chemical formula of your molecules on the left. You'll see a spot in the center for your Lewis dot structure, and you'll see a spot on the right for a picture of the 3D model. So if I take a look at, say, this molecule right here, this SiCl4, or silicon tetrachloride, if I want to see what this molecule looks like in 3D space, I'll first have to make its Lewis dot structure. As a quick reminder, silicon and chlorine, if we want to find their Lewis dot structures just for the atoms, say for silicon, I can count from the left side right over here, and I would see that silicon has 1, 2, 3, 4 electrons around it, whereas chlorine would have 1, 2, 3, 4, 5, 6, 7. Those are for the single atoms. So really the first step for this lab is kind of on a separate sheet of paper, sketching out your Lewis dot structure. If I bring up this whiteboard here and show you kind of our process that we went through in class, I would take, say, silicon with 4 electrons. In fact, let me do those in a different color. I'll do the electrons in, say, blue. Silicon has 4 electrons that we counted from the periodic table. And then each of our chlorines has 7 electrons. 1, 2, 3, 4, 5, 6, 7. So I can see chlorine has like 3 pairs of electrons and then 1 single electron. Now, if I were to repeat this chlorine 4 times, I would see that each chlorine can only form 1 bond. It only has 1 single electron, whereas the silicon can form 4 bonds. It has 4 single electrons. So to make my actual structure, my actual Lewis dot structure, I'll put a silicon in the center. Remember, the atom with the most single bonds goes in the center. And I'll put its single electrons here on the outside. 1, 2, 3, 4. I'll then start putting the 4 chlorines in my molecule around the outside. And I'm going to go ahead and arrange these so that the single electron groups, as shown here on the left, line up with the silicons. And the pairs will go in those other spots. And as we practiced in class, 2 single electrons facing one another can form that bond. And I'll repeat this process for the other 3 chlorines. Now this is just the method we went through in class to find the Lewis dot structure. And kind of jumping around here, putting my elements around the outside, lining up those single electrons so that they can bond with one another. And the last chlorine. So you can see that this process, forming that Lewis dot structure, this is what we did in class to form that 2-dimensional shape of the molecule. Now I'm going to use this as a template for the actual MoleView software. So remember this Lewis dot structure. In the MoleView, I will replicate that structure. To place an atom, you can see right here, sort of in the middle, you can see you can select from your atoms. I have to use silicon for my center atom. To do that, I'll go to this little periodic table symbol, select silicon, and then click to place a silicon atom. Ignore the right side for now. The software doesn't quite know what we're doing yet. Now around that silicon, I have to place 4 chlorines. So chlorine is actually pretty handy. It's right here. We don't have to go into the periodic table. And if you click on the silicon and drag up, you'll see that a chlorine is placed there. And I'll do this in all 4 quadrants, just like my Lewis dot structure showed. In fact, if I flip back real quickly, I can see that matches my Lewis dot structure. Silicon in the center, 4 chlorines around the outside. The only thing missing are those pairs of electrons. If I go back to my MoleView, the way we place those pairs, on the left, you can see a symbol, this A with the pair of electrons, to add those lone pairs. And if you simply click on an atom, you can see that it adds those lone pairs. So I'll click on my chlorines until they have the right number of lone pairs. Now, for your lab, this is one piece of information that you need. What I'll do is I'll screenshot this just as a nice looking Lewis dot structure, and I'll place it back in my lab right there where the silicon tetrachloride spot is. Now the next says this picture of this 3D model. In MoleView, we're pretty lucky because it's a pretty smart software. It shows you what the 3-dimensional image of that molecule is. You can see the silicon in tan in the center and the chlorines in green around the outside. I want you to actually copy paste this image as well, and I'll screenshot that and put it in my lab as well, right next to silicon tetrachloride. The reason why we're seeing these 3-dimensional shapes is because our next section will talk about the chemistry involving the 3-dimensional shapes of our molecules. So that's really the lab. I want to show you one more example to kind of show how one more function of the software. What I'll do is I'll head down to, say, HCN and show you how to do HCN. First, we need to find our Lewis dot structures. On my periodic table, H has 1 single electron, carbon has 1, 2, 3, 4, and nitrogen has 1, 2, 3, 4, 5. So going back to my whiteboard, if I just kind of clear all of this stuff and draw my hydrogen, carbon, and nitrogen, hydrogen, carbon, and nitrogen, and I place those amount of electrons around the outside. Hydrogen had 1, carbon had 4, and nitrogen had 5. I can see carbon has to go in the center because it has the most single electrons. So I'll put my carbon in the center. Hydrogen, I'll place kind of randomly on the left side, and I'll arrange its electrons so that it bonds with carbon. And then nitrogen I'll put on the right side. And I'm going to rearrange the electrons of nitrogen so that the single electrons face one another, and the pairs over here on the right. Carbon and nitrogen, it looks like are going to have to bond 3 times to form our stable molecule. And if I were to redraw this structure so that it looks nice and neat, I would say hydrogen's on the left, carbon's in the center, nitrogen's on the right. And as far as my electrons are concerned, there's 1 bond between hydrogen and carbon, 3 bonds between carbon and nitrogen. We just draw them equally. And that lone pair on the right side of nitrogen. And this really is our nice looking Lewis dot structure. So we'll repeat this in the MoleView software. Double click the trash can to get rid of what we had. Put carbon in the center. I'll click hydrogen, drag to the left. Click nitrogen, drag to the right. Now we need to put a triple bond between the carbon and the nitrogen. As long as your bond up here on the left is selected, If you click on the bond, it'll cycle between single, double, and triple bonds. Now that we're here, the only thing we have to add is that lone pair of electrons in the nitrogen, and now we have really everything we need. If I screenshot my Lewis dot structure, place it in my lab, and then screenshot my 3D model and place it in the lab, that would be how we complete HCN for this lab. And that's really it for this lab run through. If you have any questions, please let me know, and good luck.